हेलो गाइस, वेलकम टू माय चैनल स्टडी हब। मैं तुम्हारा डियरेस्ट, तुम्हारा प्यारा टीचर, तुम मेरा प्यारा स्टूडेंट। वेलकम टू माय चैनल स्टडी हब अगेन। सो हम हाजिर हुआ, फिर हम वादा किया कि नेक्स्ट वीडियो में हम ले आएंगे तुम्हारा जो केपलर्स लॉ, very important. I am sure after seeing this full video you will be able to give any type of questions regarding the Kepler's law, and one first, second, third law are there, and also gravitations I have already discussed in the yesterday video. Okay, so please see the video at full length. Okay, so let's start.
अगर तुम लोग नए हो तो सब्सक्राइब करो, वो जो लाल वाला बटन है उसके साथ स्कैम करो या फिर महफिल जमाओ, मुझे नहीं पता, बस क्लिक हो जाना चाहिए।
So Kepler's law of planetary motion. The before Kepler's, there are so many scientists are there who has also given some aspects or some notions, some theory regarding the motions of the planets around the earth, around the suns, okay, around moon. So many scientists are there. Most probably the first of very in the earlier times, most probably 140 or 142 AD, the scientist Ptolemy, जो टॉलेमी जो एक साइंटिस्ट था, Ptolemy, he has given some idea about the planetary motions, which is known as the geocentric theory. According to him, the earth, according to the geocentric means earth is the geo, the earth will be the center and different planets around it will revolve around the earth, and next it will some results has been discarded, but Copernicus, what he has given, he has given some idea about the he told that sun is in the center and other planets revolve around the sun, and it is most probably known as the heliocentric theory. Next come T. Brahe. What's the Nicholas Copernicus heliocentric? Tychonic theory क्या होता है? वो मून है जो सेंटर, वो ये अर्थ है सेंटर, ये सन है सेंटर में, विभिन्न प्लैनेट रोटेटिंग, मून इसमें क्या है, मून है सेंटर में एंड विभिन्न डिफरेंट प्लैनेट्स मूविंग अराउंड इट, एंड दैट इज द অপকেন্দ্রিক অভিকেন্দ্রিক যেটা বলতে আমরা বলেছি আগের দিন, centrifugal force I have discussed earlier video. And next come the final, who has given the ultimatums of the Galileo, okay, which is most discovery invention, the telescope he has invented, and his theory, Galileo's theory, and also the Nicholas Copernicus theory, most are the same. The sun is in the center, and within the sun most other the planets revolve around the sun, okay. This is the he also proved by discovering the telescope, and all these things finally clearly been described about the Kepler's. That is the Kepler's law of planetary motions. How planets moves around with centric, किसके सेंटर करने के बाद जो कौन प्लैनेट्स कैसे घूम रहे हो, it is been clearly been described by the Kepler's. The Kepler's law. Kepler has given 3 laws regarding the motions, okay, motions of planets. Motions of planets के लिए Kepler's 3 law दिया हुआ है. Oh, so see what are the law. So before going to the law, you have to know, I have already discussed about so many things. So many, there are contributions of so many scientists regarding this, and what is, we also know about some the center of circle. In case of circle, what we know, this is a circle, this is the center, and in case of parabolic, that is the ellipticals. In case of this, here is only one center, and this is a circumference. From the circumference, the distance between center to any point of the circumference is radius, and all the radius are same, all the distance from the center are same. But in case of this elliptical or parabolic structure, what you learn, there will be two focus, the foci. One case of foci and one has focus. Focus or foci. So this is 2-1. If this is F1, this is F2. There are two foci. One, this is first focus, this is second focus. That is the distance from the circumference of the elliptical from the focus are not same out here. Here is same, here is different distance. And in this concept as the planet's motions in not in a circular path, it is in an elliptical path. This is an elliptical orbit. The Kepler's opinion is that the planets are motion in an elliptical way. This is the elliptical orbits, and there are two focus, F1 and F2. Clear? So, and if any one of the focus, the sun is in the main one of the focus. Sun is the center, and within the center, most of the other planets revolve around the sun. So, next come and we also know, we also tell देखो in this case, this is known, two axes are there, major axis, this is minor axis. You also remind it, major axis, and this is the minor axis. This is the major axis, this is the minor axis. Equator and pole, okay? Equator and pole, minor axis, this is major axis, okay? So, let's describe the first law of Kepler. What Kepler told in his first law. In first law, what we see, in case of first law, what we see, this is the circular orbit, this is the elliptical orbit. First law, what? Any one, this in this focus or in this focus. What's a singular, plural, foci? Suppose here is the sun. Here is the sun. Suppose here is the sun. Here is the sun. Sun. In this focus, this is A position, and this is the B position. Okay, and from here, planet revolves around with this elliptical orbit. Here is the sun, and here is the planet revolves around the sun. Here is the planet. Planet revolves around the sun in this way. Okay. So what happens out there? The first law. What is the first law? What I told earlier. This is the major axis. This is the minor axis. Yeah. F1. If this is A or F1 focus. This is also focus. F2 or B. Whatever you can tell. Okay. If you write it out here F1, no problem. It was right out here F2, no problem. And this is the axis, you can join this axis. This is the AB, you can write. Okay, so what is the first law? The first law, according to the Kepler, the first law is planet revolves but move around the sun. This is sun, revolves around the sun. Planet revolves around the sun but moves around the sun in elliptical orbits. In elliptical orbits, and Sun is at any one of the foci. In any one of the foci বা foci. যে কোনো একটা ফসিতে সান থাকবে এবং তাকে ঘিরে what happens? Planets revolves around. Planet घूमता है किसको? In one of the foci of the in between two. This is the first law. তাহলে it is sun, or here will be sun there, and revolving sun is the center of the focus, and all the planets revolve. Okay, this is the first law. Clear? Second law. What second law? See, in case of second law, what happens? See out here, this is the figure. In this figure, sun is out here. Here, planets, suppose this is A position, this is moving towards this go towards B. What is see out here? A line drawn from this. So this is the area I am explaining. Now after some times, these planets move out there, this position, and then this position B, we also line joining the line out here. Okay, this is the area bounded, this. What happens out there? Suppose the planets out there in this position, after some times it traverses the distance from A to B. Yeah, and if we draw the center from the planet, center of the planet to the center of the sun, draw a line, and also from the initial position, and it is the final position, from the center of the planet draw the line from center of the sun, and if we find out the area, that is, this is the area, this area, blue color area, the area traversed by the planet from A to B, time taken also, and time taken, let's time taken is 5 seconds or 10 seconds or 20 seconds, any time is fixed. And same planet out there from A to B, this planet from here to here, this same time 5 seconds, it traverses this path. That is the area of the second for the same planet. This is the area, this is the black portion area, is area of this, then O, if OAB, EAB, OA dashed, B dashed, OAB, OA dashed, B dashed, area. What is the second law? See, what is the second law? Then it will be clear. I am telling. Second law what? That means the line joining around that is line joining what? The center of the planet to the center of the sun. Center of the planet to the center of the sun. Yes, while moving, while revolving, they sweep equal area in equal interval of time. They sweep equal area in equal interval of time. Equal interval, this area, this portion from here A to B, जाने से टाइम लगे 5 सेकेंड, यहाँ से यहाँ 5 सेकेंड. लेकिन क्वेश्चन आएगा that area of OAB equals to area of OA dashed B dashed according to the second law of what? Kepler's. They sweep the equal area. They sweep the equal area. Why? कैसे लग रहा है? क्या what we seems this area is ज़्यादा, this area is less? No. If we find out total this area and this area, it will be equal. क्योंकि let's see what I know, F equals to G m1 m2 by r square. That means distance job, if r is greater, force of attraction is lesser. If r is lesser, force of attraction is greater. The force यहाँ से distance क्या greater है, force of attraction, r greater, force of attraction lesser. तो यहाँ से force of attraction lesser, that is when any planet nears the sun. जो planet जो near the sun and away the sun, जब planet जब sun का near होगा उसका velocity ज़्यादा होगा. Velocity ज़्यादा होगा means it traverses more path in the same equal interval of times. That's why here उसका speed ज़्यादा होने से वो इतना दूर चला गया. That is the path. It will traverse more than that of this. ये planet से sun से ज़्यादा दूर में है तो इसका velocity क्या होगा, speed क्या होगा, स्लो हो जाएगा. स्लो होने से क्या होगा, या डिस्टेंस जो ट्रैवर्स होगा वो लेस होगा. तो डिस्टेंस ये जो डिस्टेंस है ये थोड़ा लेस होगा, ये जो डिस्टेंस है थोड़ा ज़्यादा होगा. इसलिए लेकिन क्या है, द सेम पाथ विथ इक्वल टाइम इंटरवल, बिकॉज दोनों का स्पीड सेम होगा. लेकिन व्हाट आउट देयर, द अट्रैक्शन, फोर्स ऑफ अट्रैक्शन सन, फोर्स ऑफ अट्रैक्शन यहाँ से यहाँ तक क्या होगा, व्हाट वी नो, डिस्टेंस लेस हो गया, फोर्स ऑफ अट्रैक्शन ज़्यादा होगा, स्पीड इंक्रीज होगा. फोर्स ऑफ अट्रैक्शन लेस होगा, डिस्टेंस इज इंक्रीज, फोर्स ऑफ अट्रैक्शन डिक्रीज. So in that case speed will be slow, so it traverses less distance, so but distance less, distance greater. In this way the area of this equals to area of this. This is the second law of Kepler. Okay, तो सन दोनों एक के फोकाई में होगा, एक यहाँ भी सकता है सन, यहाँ पे प्लैनेट होगा, तब यहाँ पर डिस्टेंस कम होगा, यहाँ पर डिस्टेंस ज़्यादा होगा. ये एरिया ज़्यादा होगा ना, ये एरिया कम हो नहीं, ऑल टाइम्स एरिया विल बी सेम. दिस सेकेंड लॉ. एंड व्हाट इज द थर्ड लॉ? थर्ड लॉ व्हाट? थर्ड लॉ क्या है, व्हाट आई टोल्ड अर्लियर, द मेजर और माइनर सेक्टर जो होता है थर्ड लॉ. थर्ड लॉ स्क्वायर ऑफ द डिस्टेंस, this is F1, this is F2, here is sun, this is major axis, this is minor axis. I have told you. Okay, a distance कम है, a distance ज़्यादा है. What is the third law? That is, third law is that the square of the time taken, the time taken to one complete revolution of revolution, it takes time. The square of the time period of revolution is directly proportional to the cube of semi major axis or cube of the mean distance of the planet from the sun. Mean distance of planet from the sun, that is the square of what? Square of the time period, जो टाइम लगता है, one square of time period directly proportional to the cube, that is the r cube, that is the cube of the semi major axis. This is the semi major axis, r, semi major axis. Okay, this is the semi major axis, half, or the distance, mean distance, average mean distance of planet from the sun. This is the third law. Square of the time taken by time period is directly proportional to the cube of semi-major axis or cube of the mean distance of planet from sun. That means t square equals to, if time period is t square, varies as r cube, we can write it, okay, or t square equals to constant, some constant r cube, some constant. That means t square by r cube क्या होगा, r cube by t square आएगा, that is r cube by t square equals to constant. This is the idea from the third law of Kepler. Okay, r cube by t square always be constant. That is distance and time period always be constant. So here pre-fall is completed and also Kepler's law is completed. Okay, so there are third law. This third law clearly been described the planetary motions, and so many questions and numericals I will solve after the 2 or 3 or 5 videos. After the videos it will be very clear to discuss the numericals. So here I draw my ends. So clearly, please clearly see the video at full length. Don't skip it. If any doubts, comment me in my comment box. I am here to describe again. I am going too fast. It's in the 11. It will be also clear. So some thing what is required, I am giving you my idea. So thank you, my students. Share it, subscribe it, and like it. Thank you.